Hi, today I'm going to explain the BFS algorithm. So we can imagine that we're in a maze and we want to find the shortest way out. So instead of going in every path randomly, we can check all possible paths step by step. So this is how the red first search works. The BFS explore a graph level by level, and it starts at the first node, in this case the node A, and checks all the direct neighbors. And then if it moves to the next level of a neighbor, it checks until it finds the destination. By this means, it ensures that the shortest path is always the first. So we can start explaining the code. First, we go through the queue containing the start node and its path. So in this case A, and the path that it can have is B, C, and D. Then we process the nodes one by one using the pop left function. That is the first one, first in, first out type of uh, type of sorting. Then we check all the neighbors of the current node. As I said, the current neighbors of my starting node A can be B, C, and D. And if we go to a node, or if we search the end node, by this mean, by checking the neighbors of each possible path, we if we get to the end, we return the path plus the end node, giving or returning the the new path. So why is BFS a good good algorithm? It's because it always finds the shortest path in an unweighted graph, so it avoids all the unnecessary deep searches like the DFS that goes through every single option, and it's efficient for problems that practical problems like navigating cities or going through paths. Okay, so if we run the code, we can see that from A to the from the node A to the node T, we have the path A goes to C, goes to H, and then it goes to O, and finally we get to our end node that is T. If I change this path by giving the option of a shorter path like T and run it back, I can see that my return or my shortest path now goes from the first node to the second node B, and finally it gets to the end node. So BFS explores level by level, ensuring the shortest path is found, and it's a great option for path problems like maps and networks.